What I'm going to do right now is actually have us. You don't actually want to hear my rock band voice. What I'm going to do is actually have us take a step back and look at the broader market around Agentic AI and look at the dreams that we have for the future that we're starting to build today, but the actual reality of what is actually happening on the ground. So to do that, I'm actually going to first start us with a little backtracking into the journey that we've been over the past 2.5 years, which is just crazy to think that it's only been 2.5 years. So 2.5 years ago was the first time that many of us were exposed to this brain in a box. We got our first taste of large language models in an easily usable user application in the form of ChatGPT. That very quickly evolved into enterprises saying, well, that's really nice that this is like a cool language model, but it's not tied to my enterprise data. It can produce hallucinations. It's not secure, all these different things. So then throughout 2024 and into this year, we've seen enterprises wanting to connect large language models to their enterprise data. So we've seen this manifest in retrieval-augmented generation, as well as the use of fine-tuning of models and other approaches to make large language models really grounded in the answers and the content that are relevant to your enterprise. But even with that, that's not enough. Now, as we've been hearing about today, we've moved into a world where we actually want to connect these brains not just to information, but actually to actions in the outside world. And so we've very quickly moved from this idea of, oh, all of a sudden we have these large language models to let's have them do something complex and active in the enterprise. But what we've seen with our clients and in the broader market is that most enterprises are still struggling to get past that second stage, still really trying to figure out how do we get our data in order, how do we get our processes in order so that we can implement things like retrieval-augmented generation to provide better information and content to our clients and to our employees. And so that has really necessitated for enterprises and for technology companies to all work together, work very collaboratively in order to advance this space, in order to make these very secure, very accurate, precise agentic applications that we actually want for the future, rather than semi-precise applications that can fail that might need a lot of human intervention. So Agentic AI has a ton of potential, but there's some caveats that we have to touch on today in order to recognize the limitations of what is possible. So in Agentic AI today, we have a lot of opportunities around enabling more open-ended processes to support key decisions with broader workflows, having higher-level strategic goals, and also to drive better employee and customer experiences. Now, these are all well within the reach in the next couple of years, but we have to overcome some important technical and organizational challenges. So one of the key challenges that we have to overcome is the testing and validation piece. So we'll talk a bit more about this later, but there's some real challenges around making sure that agents are doing the right thing and doing this at scale. Then we have challenges around interoperability. So you may have heard of, it was mentioned earlier today, the Model Context Protocol. There's a number of other emerging standards for this, but interoperability between different agent ecosystems is still a challenge. And then we have challenges around securing these things. Are we actually getting the right content back? Does this user have access to this content? And then kind of wrapping up all of these things, we have the change rate. And so that change rate goes at multiple different layers. There's the change rate in the models at the, or let's say the hardware at the lowest level. Then we have the changes in the models where we're having new models come out every week from major and minor providers alike. We have lots of change in the actual data structures themselves. So looking at vector databases and things like that that most enterprises are not used to having to incorporate into their actual data management practices. So we saw a lot about the creation of embedding pipelines for RAG earlier, but that is not necessarily something that is easily accessible to most different companies. And so we're seeing a real need, again, for this collaboration between end users, technology companies, the providers, and the service companies that help them build this. Now, when we're talking about going to agentic AI, this isn't just like an on or an off switch. It's not a 1 or a 0. It's actually an evolution. And the way that we describe this evolution is kind of along these two axes of action and agency. So action is, what are you actually doing in your enterprise? And agency is thinking about, okay, what amount of intelligence and strategic decision-making do I have to make those decisions? And when we look at this progression, we see first that there are all of these non-agentic systems that are sometimes being labeled as agents in the market, and I can kind of call it these agent-ish systems. So we have things like robotic process automation, we have predictive analytics and machine learning, standalone large language models, as well as retrieval-augmented generation. And all of these things provide significant value to enterprises. They're providing really good behaviors and results, but they don't have the flexibility and broader planning that a lot of the agentic systems that we're starting to build do. Now, I also want to touch quickly on RAG here at the top, retrieval-augmented generation. So we're seeing a lot of folks build AI agents that are not necessarily actually taking actions within the enterprise system as their end result. They're not doing things like we saw in the claims processing example where it was actually processing the claims in the endpoint. Most of these agents today are simply, they're doing complex information retrieval, but they're not actually taking an action in the system. They may be delivering information that is more contextually useful, you can make better decisions with it, but the agent itself is not actually making that decision. And so when we do actually get to that point, we start to see this agentic evolution. So we kind of describe it in a few different stages that I'll touch on as we go through in the complex flow and multi-flow and any flow agentic stages. Now, to talk about this a little bit more specifically, this is what we see as an agentic system today, and I think this is a generally agreed upon kind of atomic view of agents. So you have your user or your process, and I think it's very important to remember that these are both user and back-end process systems in the same way that applications are both front-end user-facing as well as back-end. And then that user or process emits their inputs in natural language. Typically, we are starting to see these done in a more templatized format, so you're not, as an end user or as the initiator of a process, just entering willy-nilly your own preferred prompt in the way that you express yourself in natural language. We're seeing it done much more in a templatized format or other types of semi-structured format to deliver those prompts so that the models can understand them better. And then the content goes to that planner or orchestrator. Now, the planner or orchestrator piece, this is the really differentiating thing about agentic AI that allows it to do this higher level planning, processing, and decision making. And when we look at these planners and orchestrators, a lot of people may think of these just as a large language model, even just as a reasoning model. But when we see enterprises actually start to implement and build agentic AI, these orchestrators and planners actually have a combination of non-deterministic or semi-deterministic large language models and other foundation models as part of their execution, but also they incorporate more hard-coded or specific business rules to align the behavior of the model to your specific outcomes. Now, once it has this orchestrator and can start to build a plan, then we come down to one of the really big challenges in this space. So getting your data sources and context in order. Now, I touched on this earlier, but in agentic AI, it's important to recognize that you're dealing with very broad sets of data, both in terms of the format as well as how you're processing them. So, there's the embedding and vectorization and all that good stuff, but you also need to combine that with your relational databases and other structured data in order to produce the best kinds of decisions and outcomes that you want. For example, if you have a very large, let's say, time series structured data set, you are not going to be able to process that with just a large language model or even, there's emerging time series models today, but not too many of them. You're going to have to use a more traditional machine learning or analytical process in order to make a decision about that time series data. So when you're actually leveraging or when you're putting together agents, it's important to think about different levels of determinism and non-determinism, as well as different types of data sources that go into the building of the agent. Now, that's all well and good, and that gets us good information, but the ultimate step here is the actual tools and services and workflows that these agents integrate with. And so once we have all this information, we actually need to take an action within the system. And so we can kind of see in the previous examples that was issuing the approval or the rejection of that insurance claim. And so that then produces the action back to the end user. Now, what this looks like in practice today is what we call complex flow agentic AI. So it's not that simple flow, very straightforward system that we just saw. It's very similar where we have the planner and the orchestrator, we have data, tools, and workflows, but this is all contained within a single semantic layer or a single data management system. So essentially this means that you have an overall understanding, as we were seeing earlier, of what the data is, what is available to you, and what you can access. And that is what actually enables these agents today to be tested and validated and be able to perform with an enterprise level of acceptable accuracy as opposed to much lower levels of accuracy that we wouldn't accept. So I'm going to very quickly run us through sort of how we're seeing agentic AI used today, and then we'll talk about the caveats really quick. So today's agentic AI is really augmenting workflows rather than replacing them wholesale. So this example is going to be just going through a quick customer targeting example for marketing. So in this example, first we want to build our business objective. So today, we might use something like a deep research agent, if this build will happen correctly. There we go. We'll have a deep research agent, which essentially, there we go. A deep research agent which will basically go out to our internal data, it might go out to the web. You can think of this as the enterprise analog of Google's deep research or OpenAI's researcher tool. So that will go out, identify market opportunities based on public information as well as our internal enterprise information and suggest who we should target and what kind of plan we should have. Then we'll take it to what kind of strategy should we use for this. And here's where we actually might use that structured data combined with natural language to use the natural language query to look at all of our customer data to understand what types of insights and what type of demographics and other types of targeting information we might need to have on them. And then from there, we can actually take it to our audience agent. And with each of these steps, I should have described this at the beginning. Each of these steps is being done by a human executing these agents and then passing the insight on to the next human in the workflow or doing it themselves with a single human operating. So then once we have our audience, we're going to use a Gen AI model to create on-brand and brand-safe imagery. Typically, that is text today. We see a relatively limited use of images and video in generative AI content used in production. It's mostly used in ideation and development at this point. And then the fourth model, we're passing on to our automation agent, which is going to select the best performing channels, build creative, and things like that. And then finally, we'll have an agent that will build dashboards and recommend optimizations for the next iteration of this application, which might manifest as something along the lines of the management tool that we saw at the end in the demos. Now, this is how we're seeing AI agents used today in the enterprise. They're typically designed for very specific and more directed workflows, and they have a human in the loop to validate the output before it's sent on to somebody else. Tomorrow, we expect to see agentic AI actually orchestrating and executing these overall workflows, and I think we saw a taste of that today. So tomorrow, it's going to be much higher level where you give a single prompt, probably more complicated than this, but not too much more complicated, and then from there, it'll pass it to an orchestrator agent that will understand what the problem is and then choose from a series of other agents what the process should actually be. So here it'll start with a campaign brief agent, pass it on to a creative agent, then pass it on to that reviewer agent, and then on to a MarTech agent for building the appropriate tools. And then we actually have the entire life cycle of this marketing opportunity identified and executed against using an agentic system. Now, building this requires a lot of effort and is quite a big challenge for people to put together today. So this is really what we're seeing coming on in the future. Now, if we can get to, there we go. So we have the future in Anyflow agentic AI. I'm not going to spend too much time on this in the interest of time to talk about the caveats because I think it's really important there. But the next step of this is having agentic systems that interconnect to external agent ecosystems as well. And this is one of the, I would say, big steps that we have to overcome in order to make agentic AI really ubiquitous across the enterprise and across our different businesses. So I will not actually go through my example because I have wasted my time. But I'm actually going to talk quickly right now about the caveats and the challenges here. So the three big challenges that I'm going to talk about are security and testing. So this comes in primarily at the actual agent testing stage. So we see a lot of folks that are deploying agents in their own data governance ecosystem here, but a lot of the testing and validation, the checking of whether the actual outputs of the agent are correct, ends up being a relatively manual exercise in a lot of cases. And that's because in order to judge the output of a lot of these agents, you actually have to have some kind of nuance and understanding that comes with something like human perception. Now, that is being addressed to a certain degree with things like large language models as a judge and some other techniques, but there are some challenges with that even. Say you're trying to use a large language model as a judge in an insurance scenario. That is not necessarily going to be the best judge for a manufacturing quality scenario. So if you're using these large language models as a judge, they end up being relatively brittle, and so we end up having to go back to having a lot of human testers in the agentic ecosystems. And that's compounded even further when we actually have to test the interactions with external agents and with the interactions between these external agents themselves. So that's a big challenge around the testing side, though we are seeing a lot of advancements, and I think we saw a good step here earlier with the automated RAG pipeline that would basically choose the model for you. That can help overcome one of the big challenges that a lot of folks have when they're getting started here, which is just what model do I even, or what 5 or 6 models do I even start to choose from to see which one works best for my use case. Then we have this big set of challenges around interoperability. So when we look at the agentic stack, you can kind of divide it into 2 or 3 different layers. I've chosen to divide it into 3 here, where we have our tools and data sources, internal agents and orchestrators, and then our external agents, tools, and data sources. And at this point, it's relatively straightforward to integrate agents that are internal with your internal tool sets. It is much more challenging to integrate this with external tools, agent ecosystems, and applications. And we're seeing a variety of different approaches. You can see some of the examples here on the side, pardon me, to addressing this problem. And at this point, we've seen MCP emerge as, I'm hesitant to say it's a standard because we have so few large-scale in-production applications using MCP, but that is the protocol that I've seen by far the most adopted amongst enterprises. Like, there's not even, I would say, there's not a close second whatsoever. I would say maybe a distant second is things like LangChain and LangGraph, but it's like not even at the same level. So the interoperability challenge is something that I think we really need to rely on our partners for, because there's not a standard set of ways to interoperate between these systems as yet today. And finally, to close myself out, there's this ongoing and big challenge around the innovation side of this. So delivering next-gen agentic, next-gen AI, you really can't do it alone, because the stack, as you see here, this is the AI platform stack, is getting really, really complicated. In years past, the agentic AI stack, or the AI stack would really include most of the elements here at the bottom: data management, model development, training, and model serving, and also the governance. And it's really only in the past couple of years, and even just this year, that we've started to see AI accelerators become a key part of the stack, and as well as driving more application development within the AI platform stack itself. And that AI accelerator layer is really where a lot of the innovation and transition is happening. So, people who have day jobs, unlike myself, who can't look at this all day, every day, are going to have a very hard time, keeping up with the innovation and following what is progressing. I even have a challenge doing this myself. And so I think it's really, really important to remember that, we are all learning, we are all evolving in this space, and really no one is the be-all, end-all expert of this stuff, because it is still constantly changing. And with that, I'll say thank you very much, and appreciate the time today.
So much. I think while we have you, if it's okay, I'll ask a few questions. Man, when they handed you that mic, I was ready to rock out, man. That was awesome. We've talked a little bit about the barriers to entry and the roadblocks for large companies trying to implement, get into production, and scale AI. What are you seeing as the biggest roadblocks that enterprises are facing today?
I would say that data is probably the biggest challenge at the beginning. I think we've talked a lot about that, so it's no surprise to anybody. But it comes in a couple of different forms. So one of the forms I talked a bit about in my presentation is the fact that we now have this whole concept of creating embeddings and using vector retrieval as part of our data management and as part of our data access method. And a lot of professionals aren't super familiar with well, they might be familiar with creating embeddings and using vector databases, but they're not super familiar with optimizing all this stuff. They might not know the difference between a native vector database versus one that is just kind of mapped onto an existing database. And so that can be a huge challenge with actually getting going and having the right data for your agents, which is going to be the actual driving factor towards their accuracy. But I also want to call out that we are seeing a really big challenge for folks at the actual implementation scaling stage. And that comes in a really very non-technical form, and that's just like actually putting the resources into change management and into investing in your people skills, and also making sure that you're building the right application for the right people at the right time really comes into play. Because especially if we look at the release of general purpose productivity copilots over the past couple of years, that's been an area where we've seen a lot of wasted effort, a significant significant amount of wasted energy just because when these things are deployed, there's not a lot of change management around it to help people understand how to use these tools properly, right? So, for example, like if I have a copilot in my word processor, that's great. I'm not me. I'm some random employee who likes technology but isn't up on all of the new breakthroughs and the new innovations. I don't actually know how to make best use of that tool unless I have training and guidance around it. I think we can see this play out in the way that we see a lot of the actual user interfaces that are being built around these things come about today, where we're increasingly asking end users to input broad-based prompts themselves. Like it's a much less common scenario to have to type in a full expression of what you want as an end user for a specific task, as opposed to saying, all right, I'm going to choose from a couple drop-downs that'll help construct a prompt for me from a template, or it might just auto-generate it from me. So that change management piece, I think, is really, really important for actually achieving success with these things once you've actually gotten the application built.
I agree, and I think that's exactly why we were focused on the user experience. And a little inside story was I was supposed to do one of those demos, but I'm a terrible typer. So they're like, it'd just be awful for people to watch you trying to type, and that's why Saurabh actually created that voice activation for me, so I appreciate it. Next question, Umesh talked about composability, and you talked about this constantly moving architecture at every different layer. And then companies trying to keep up with that pace of change, maybe constantly having to re-architect that AI tech stack. How important is composability with respect to that?
So I think composability and integration and mutual communication is, it's been very important for the enterprise over the past 10 years, but it's becoming even more essential today. So as we're seeing, the pace of change not slow down, but continue to accelerate, there's going to be a need to enable your tools and your platforms and your data sources to be able to plug and play, quote unquote, plug and play into whatever future systems you need as easily as possible. And so one of the ways that I think we're starting to see that happen is through the emergence of things like the Model Context Protocol, which, putting aside the goods and the bads of the protocol itself, the approach of having essentially a high-level interface to your entire set of enterprise tools on the back end, where your clients don't have to know every single API connection that they have to make every single time, allows you to be a bit more flexible in how you're putting these things together as an end user, and also in terms of what you're providing as part of the platform.
No, absolutely. That's why we sort of see it as a core principle with respect to what we're offering from a platform perspective. Now, next question, there's a lot of hype around foundational models, right? We're hearing about that all the time, but we're seeing more interest in enterprises building or fine-tuned small language models, not only for sort of the industry-specific knowledge, but as Umesh and the demo pointed out, the cost savings associated with that as well. What are you seeing in the market with respect to SLMs and the move to there versus the bigger foundational models?
Yeah, I think it's a really interesting aspect of the way that these architectures are emerging, because there was this discussion earlier this year, are small language models going to take over? Are they going to replace the large language models? And anybody who knows how a small language model is built, you actually need an instructor model in order to build it. So saying that we're going to do away with mega models is a kind of ludicrous idea overall. But the way that we've actually seen them come into organizations is with respect to creating applications that are much more efficient to run overall, as you were saying. So I've spoken to a number of different clients who have basically taken a proprietary model and then used a combination of fine-tuned or a distilled open model. Distillation is part of what helps you create a small language model as a replacement for those proprietary models. So there was a major North American telecom that was using GPT-4 as part of their call transcript processing to create sentiment and other types of metadata out of the call transcripts. Well, they replaced GPT-4 with a set of 3 small language models that got up to, I think it was like 95% of the accuracy of the previous model, and it was something like 30% of the cost. So we're seeing folks start to do this, but think we've only seen it really done at companies that have a lot of tech resources so far, because up until about the end of 2024, there was not a really tooling-based approach to building a fine-tuned or a small language model. You really had to kind of build up this code yourself. But over the past 6-8 months, we've seen through all the hyperscalers and a number of other providers as well, they're basically offering single-button fine-tuning and single-button distillation of models. So that ability to create these models has, the barrier to that has dropped a lot, which is making them a lot more appealing to folks. And I think, especially as we look at more of these agentic use cases, the use of small language models is going to be really important for some of these things where it's a very specific type of response or outcome that you want. So, you might not need a, let's say, in the claims example, you wouldn't need necessarily like a mega model to say, okay, yes or no on this particular claim if we're looking at these pieces of evidence, because it's a very clear and specific set of information, specific approach, so you can test against that space much more easily. And it might actually be that you want a less deterministic output than you would get from a more standard language model, so you might want to fine-tune it and turn down the temperature so you get a much more directed output, yes.
No, that's great. And and Mesh had sort of taken us through the layers of the stack, and I think one of the most important elements with respect to the knowledge layer is the fact that we call it an SLM factory, or partners like KPMG taking the platform and being able to create custom SLMs for enterprises. Now, sort of to sort of play off on that, in the last few months, we've seen growing interest, particularly in areas like Europe, with the ability to control the deployment of AI, whether it's on cloud, on premises, or to keep data in their own environment. We talk about it in terms of sovereignty. Are you seeing a similar trend as well, similar concerns? And what advice would you give to organizations who are thinking about that problem?
Yeah, so I've definitely started to see what I would call a regionalization of AI over the past 8 or so months. I think, we can see the release of, and not just the release, but the popularity of things like DeepSeek and Qwen and some of these other models coming out of East Asia, as well as things like Mistral for the EU, where we have now these open weight models that are trained within these specific regions that some companies might be more comfortable working with than the proprietary models that might not be hosted in their region, but they have less control over and less access to. And I think, as enterprises are looking at this, it's important to recognize that when we're talking about AI sovereignty today, there's the sovereignty of the data, like wherever the data lives. There's a sovereignty of the model itself. So if you're using a proprietary model, like what region is that model actually living in? And then there's the third piece of like what data is going where. So like what does your data in transit actually look like? And all three of those pieces are really important for building, a sovereign AI system that you have full control over. Then there's also, the challenge of like, what do we put on premises versus what do we put in the cloud around this stuff? And there's, I think, a lot of specific decisions that have to be made because, as you all were alluding to before, nobody wants to move their data to an entirely new system and lift and shift everything. And so what we've seen is, also an increasingly kind of multi-cloud world start to emerge, whereas, a number of years ago, people were kind of trying to concentrate all in one cloud, and now we're seeing a much more diffuse approach to that.
Yeah, absolutely. Actually, sort of picking up on that, and enterprises are still struggling with fragmented data. We recently partnered with a major insurance partner who, in the US, as a design partner to deploy data agents to really make their systems more efficient. How big of a barrier is the data issue with respect to more broader production level deployment of AI?
So that's one thing that really depends upon the company that we're talking to. So this is really, I think the barrier is a measure of the readiness of that company to start building AI applications. And I think that it's important to recognize, that you will have data at your company for building some AI application. And it's likely that, if you are building, or soliciting use cases from, your employees and stuff like that, that you're going to have a list of 100, 200, maybe more use cases. Those are the general numbers that I see at this point in time. So It might be that, the data that you want for the particular use case is not there for this particular use case, but maybe there's other use cases in your prioritization framework that you do have the data for, or that might be easier to access. So it can be a really big barrier for scaling, and it can be a big barrier, especially if you're myopically focused on like one particular use case. But enterprises have lots of data, lots of opportunities, so it's only as big of a barrier as you let it be. But that also doesn't mean that you should not invest heavily in data management, governance, and readiness. We're seeing a lot more, an increase in strength of the tools for data lineage, governance, data cataloging, and things like that. And all of those things are important, not just for getting access to the data for building the AI applications in the first place, but that is also crucial for auditing and reviewing the performance of these applications when they're in production. Much less they're actually important for building more standard machine learning models for doing predictions and forecasting and things like that.